Hello, everyone. I'm Worapan Kusakunniran from Mahidol University. I'm the representative of my research team to present the paper in KC 2022. So our work is about the measurement of tongue motion using optical flow on the segmented area of the tongue. Today, we're going to talk about the introduction, the proposed methodology, the experiment and discussion, and also the conclusion of our research work. Why we need to do the tongue segmentation and also the estimation of the tongue movement, because we need to do that for the medical diagnosis, the rehabilitation, or the progress tracking of the abnormality of the tongue. So when the doctor or the human expert want to see the abnormality or the to do rehabilitation or also progress tracking of the rehabilitation, they have to look at the ability of the tongue movement. So it is very important to investigate the motion and abnormality of the motion of the tongue. So in terms of the research work of the computer area, so we focus on segmentation of the tongue and also continue to the detection of the movement of the tongue. Okay, as you can see from this picture, the clear challenge that we have from this kind of research topic is the way to segment the tongue and also the way to track the key joint of the tongue in order to get a motion. It's very hard because the tongue have a small key point or small landmark, and also the intensity or the pixel information is quite similar to the skin or the face color. Therefore, to segment and also to track the motion is quite difficult to make it practical and also make it have the high accuracy in the real world scenario. So this is the main challenge, and this is the beginning of our research project. Okay, in the related work, existing technique, so of course they can have the manual process for the human expert to have a look on the motion. So we can ask the patient to move the tongue to according to the direction that we want, and the human expert and can monitor on the actual action that the patient move in real time. But in that way, it's not very accurate because it needs to have the experience. It rely on the experience of the human expert in order to estimate and see the abnormality of the tongue movement. So in related work, they also have some conventional technique that use the spatial equipment to investigate and estimate the motion of the tongue by using some spatial machine like ultrasound, X-ray, or MRI in order to have a look on the clear motion of the tongue movement. And in this work, also it rely on MRI scanner to using the harmonic-based processing to calculate the trajectory of the tongue in order to estimate the motion that happened by the tongue movement. Also, in the year 2018, this one rely on ultrasound image and use the technique of particle filtering algorithm. They represent the tongue by using the information like a shape, scale, and position in numerical representation, and then use that to track the motion of the tongue area. This technique is quite robust, especially to the rapid movement of the tongue. You can try by yourself. Usually when you move the tongue, it's going to be the quick movement or the rapid movement. So it's very hard, even for the human expert and also for the computer machine, to get or estimate the direction and magnitude of the movement of the tongue. And also this technique in 2018 is kind of robust to the poor quality of the image resolution as well. Okay, but what we have talked so far, they need some special machines, special equipment to capture the detailed movement of the tongue, or it could rely on the expertise of the human expert, the experience of the human expert. But we want to make it flexible for more patient and also reduce the use of the special machine, special equipment. We develop the technique based on the optical flow based solution. Okay, so this is the flow that we have in our solution. We input the video or the sequence of the image from the tongue movement video, and then we track the ROI, which could be the region of the mouth and also the segmented area of the tongue we have to attempt here in this research project. And after that, we apply the optical flow algorithm to get the motion of the tongue, okay, either in the mouth area or in the segmented area of the of the tongue. And for the optical flow, we also have two subtypes to attempt here is the dense optical flow and also sparse optical flow. After that, we combine the information of the motion that we get from optical flow to calculate the average motion vector, and then we return the vector as the final output to be the motion of the tongue. It report in terms of the vector. That means it could represent the motion of movement and the direction of movement of the tongue. Okay, and then after we change the video into numerical format, the human expert can look at that and to check out the abnormality of the movement. Okay, like I mentioned at the beginning, in this work, we have to attempt for the ROI. The first attempt, we detect the mouth location, the mouth area, okay, by using the max margin object detection or MMOD technique. And we can get the output as the mouth, and we enlarge the mouth area a little bit to cover the tongue. And the second attempt, we try using deep UNet to get the segmented mask of the tongue. And then the first attempt, we apply the optical flow on the mouth region. The second attempt, we apply the dense optical flow on the segmented area of the tongue. Okay, like you guys may know that the optical flow is the calculation of the movement of particle or location or key joint or key position in X direction and Y direction across some period of time, or delta t, or it's equivalent to the derivative respect to X direction and derivative by Y direction for getting the motion in both direction of the movement. Okay, and for optical flow, we can have dense optical flow and also sparse optical flow. The dense optical flow, it applies the calculation on every single pixel that we have in the image, in the video. But for the sparse optical flow, we apply the calculation on the key pixel only, or the key point only. Okay, but it seems to be like a sparse optical flow should be more robust than the dense optical flow. But for our special case on the study on the tongue movement, the tongue not really have the spatial key joint or some texture that can be easily tracked. So at the end, you're going to see that the dense optical flow will be our solution instead of the sparse optical flow, but we apply the dense optical flow instead of on the whole image, we apply on the ROI. Okay, so after we apply the optical flow, we use the select the extreme motion and ignore the noise vector by using the IQR technique. And after that, we convert to the average motion vector, as you can see from the equation here, that can report both direction and magnitude of the movement between two frames of the tongue. Like you can see in the picture that we captured here, the first picture is the first frame and the second picture is the consecutive frame. We want to calculate the motion of the tongue between two frames here. And the output you see from the last picture in the red color is represent the direction of movement and also the magnitude of movement that we get from the average vector of the optical flow. Okay, and we test it on 5 participants as the initial study, and we take a few frames for a few seconds that can represent the complete motion of the tongue. And after that, we compare the segmented motion with the ground truth that labeled by the human expert, and then calculate the MSE to evaluate the performance compared to the ground truth. Okay, the first attempt, we try, as usual, as the other techniques, on sparse optical flow on the whole image. But it turned out to be quite poor, quite bad, because it's involved in some, it's too sensitive. It can detect the change of intensity or the light intensity change when people walk by in the wall area, in the face area. It could be counted as the motion of the tongue, but actually they are the noises. So the dense optical flow on the whole image is not very accurate. It's going to detect the key joint like a texture of the shirt, texture of the background instead of the tongue area. So we try to apply, instead of the sparse optical flow, we use the dense optical flow, but on region of interest. The first one is the area of the mouth as a region of interest. The second attempt, we apply on the segmented tongue area as a second attempt, but both of them, we apply the dense optical flow. Okay, and this is the output. We compare by using key techniques, the dense optical flow on ROI of the mouth region, and the dense optical flow on the ROI of segmented tongue region. Okay, we apply on video 1, 2, 3, 4, 5 here, and using MSE, and we report in the final column here as the average MSE. You can see that the best technique we can have here is the apply the dense optical flow on the segmented tongue region. That means our technique is rely pretty much on the quality of the tongue segmentation. In here, we use the deep unit to train the model to segment the tongues, and then it turned out to be quite good. But for some picture or some video, we have some noises on the segmented area of the tongue that reflect to the errors that we could have in the estimation of the tongue motion. So in our continuous work, we try to extend our quality, our performance by improve the techniques on tongue segmentation. And after we get the segmented area, in many cases, we still have the errors, the whole or the non-complete segmented tongue. We try to apply the techniques to post-process or to fix the mistake that can happen on the segmented area of the tongue. After that, we apply the technique on getting the major minor axis on the ellipse, cover the tongue area, and then use the minor and major axis to estimate the motion between the axis across the consecutive frame in the tongue video. Okay, so that's pretty much for this project. At the moment, you can have a look more detail in our paper, or you can send us the email to get more information about the technical detail and the existing work and the continuous work that we try to improve the performance of this research. And also, we also welcome for the collaboration. And if you're interested in the similar or the same topic, we can share the data set, or we can share the result or the finding that we have at the moment. So any question you can ask after this. Thank you very much.